Hello friends, this is Gangadhar from Maths Gangadhar. In this video, I am going to discuss about the left hand limit, right hand limit, what it is, why this, and how to calculate these left hand and right hand limits. In the last video, we discussed about the introduction of limits, and we gave a notation for the limit as limit x tends to a f of x is equals to L. See what it is explaining. Limit x tends to a f of x is equals to L means f of x is approaching to L as x is approaching to a. That means if f of x is very closer to L, then as x is in the closer region of a. That means if the values of x are changing in the surroundings of a, then the values of f of x are changing in the surroundings of L. Surroundings means usually the surroundings are nothing but neighborhood. Who are our surroundings generally? The neighbors are our surroundings. And surroundings of a is nothing but the neighborhood of a. Mathematically we call it as neighborhood of a. That means if the values of x are changing in the neighborhood of a, then f of x changes its values in the neighborhood of L, then we say that limit of f of x is L as x tends to a. That is the sense. In another way, as x is running towards a, the values of x, f of x are running towards L. That is mathematically notated as limit x tends to a f of x is equals to L. See what we are saying here. The values of f of x are running towards L as x is running towards a. X is running towards a. From which side it is running? Sometimes the values of x are running towards a from the left side, and sometimes the values of x are running towards a from the right side. We need to keep in mind that x can be 1. X should not be a. X should not be a. X is very near to a, but we don't consider x as a while calculating limit x tends to a. See, since x is closer to a from the left side, at that position, as if f of x approaches to L, that is called left hand limit. And if x is running towards a from the right side, and f of x is running towards L, then we call it as right hand limit. There are different cases. In some cases, as x is approaching towards a from the left side and as x is approaching towards a from the right side, in both the cases f of x is in the surroundings of L, then we say that in that case both left hand limit, right hand limit exist and the limit exists. But in another case, if x is running towards a, f of x is approaching to some L1. If x is running towards a from the right hand side and f of x is approaching to some other number L2, that in the sense the left hand limit of f of x is L1 whereas the right hand limit is L2. In that case we say that left hand limit exists, right hand limit exists, but these two are not equal, so limit not exist we will announce. See, to discuss all these things, I have certain examples here. So I am moving with a graphical example. See, this is the graph of f of x. This is x-axis, whereas this is y-axis, and we are familiar with the coordinate axis. This x-axis represents the values of x, whereas this y-axis represents the values of f of x. Now what I am going to do is, I am going to find out left hand limit, right hand limit for this function f of x. Okay, at different points like -1, 1, 2, 3, like that. See, if you look here at the point 0, see at the point 0 I am going to check the limit, specifically left hand limit and right hand limit. So if x is changing in the surroundings of a, that means we need to concentrate in the surroundings of 0. See, if x is moving towards 0 from the left side, then f of x, the graph is moving towards 0 from the left side. And if x values are changing in the right side of a, that means f of x is moving towards 0 from the right side, then also the graph moves like this. So in both the cases the graph is approaching to 0. So at 0 the left hand limit is 0 and right hand limit is also 0. Right? See, to get a clear idea, move for some other position. See, for suppose if you say it as 1. See, we are going to check in the surroundings of 1. If x is moving towards 1 from the left side, at this case if you observe the graph is here. The graph is approaching to 2 from the left side. See, since x is moving towards 1 from the left side, graph is approaching to 2. And if x is moving towards 1 from the right side, the graph is approaching to 3. See, this is the region for 2 actually. So, if x is moving towards 1 from the left side, graph is approaching to 2. And if x is moving towards 1 from the right side, graph is approaching to 3. Right side values are approaching to 3. That in the sense, here the left hand limit of 1 is 2, whereas the right hand limit of 1 is 3. And if you check for point 2, see in the surroundings of 2, if you observe, these are the surroundings of 2 as well as I am collocating the graph also. If x is moving towards 2 from the left side, graph is moving towards this point. Actually the point is corresponds to 2. The graph is approaches to 2. And since x is approaching to 2 from the right side, again the graph is approaching to 2. So that in the sense, the left hand limit of 2, the left hand limit of f of x at 2 is again 2, and the right hand limit of f of x at 2 is again 2. But if you observe here, at 2 the graph is not defined. At 2 the graph is not defined, but in the left side of 2 the graph approaches to 2, and from the right side of 2 the graph is approaching to 2. So here the left hand limit is 2 and the right hand limit is also 2. Right? Then try to check in the surroundings of 3. These are the surroundings of 3. If the graph is moving towards 3 from the left side, see the values of x are running towards 3 from the left side, then the graph is approaching this point. This point is corresponds to 1. So the graph approaches to 1. So the left hand limit is 1 at 3 for f of x. And if x values are running towards 3 from the right side, so the values are running towards 3 from the right side, in that case the graph is like this. See, for the right side values of 3, the graph is like this. Since the values are moving towards 3, the graph is approaching to this point. This point corresponds to -1. So the right hand limit of the function at 3 is -1. So if you observe, at 3 the right hand limit is -1, left hand limit is 1. At 2 the right hand limit is 2 and the left hand limit is also 2. At 1 the right hand limit is 3 and the left hand limit is 2. And at 0 the right hand limit is 0, the left hand limit is 0. Then what to say about the limit of f of x at -1? And if you observe, at -1, if you move from the right side towards -1, the graph is moving towards the point 1. So the right hand limit of the function at -1 is 1. But if you move towards -1 from the left hand side, here the function is not defined. Since the function is not defined, then no need to check the limit value in that region. So usually we announce that there is only one limit, and that limit is the actual limit. Limit exists and that limit is 1 itself. See, if you observe the values on the f of x, -1, 1, 2, 3 are the values of a, and the values of y-axis, -1, 1, 2, 3 are the values of L, right? As extends to 1, you need to announce limit extends to 1 f of x, right? See, again if you observe, at 0, the left side limit is 0, right hand limit is also 0. Both are equal. In that case, we announce that limit exists and that limit value is 0. But at 1, the left side limit is 2 and the right side limit is 3. Both are not equal. left hand limit exists and it is 2, right hand limit exists and it is 3, but limit not exist in this case. It is 2, the left hand limit is 2, right hand limit is also approaching to 2. So in the region of 2, left hand limit is 2, right hand limit is 2, both exist and both are equal, so limit also exists equals to 2. Okay, and then at 3, the left hand limit is 1 and the right hand limit is minus 1. Left hand limit exists and it is 1. Right hand limit exists and it is minus 1. But those two are not equal, so limit not exist. But in this case, at minus 1, right hand limit actually not defined. Okay, right hand limit not defined, and then left hand limit, the left hand limit is not defined and the right hand limit exists. So directly we announce that the limit value as 1 at minus 1. See, here we are discussing about the limit values. Okay, see, everything is represented like this. I am going to give you the mathematical notation for what we discussed now. See, at minus 1, from that limit extends to 1 plus, if you move, see minus 1 it is, limit extends to minus 1 plus, if you move towards minus 1 from the right hand side, so since it is right hand side, we are taking it as minus 1 plus, which indicates that right hand limit, the value of f of x is approaching to 1 here. So right hand limit is 1 for f of x at minus 1. And the left hand limit is actually at this point is not defined. Okay, and then coming to 0. Coming to 0, the left hand limit extends to 0 minus f of x. The left hand limit, since x is approaching to 0 from the left hand side, the graph is approaching to 0, the limit is also 0. Again, the right hand limit extends to 0 plus f of x is again 0. Since x is approaching to 0 from the right side, again the graph is approaching to 0. Then again the left hand limit at 1, limit extends to 1 minus f of x. Limit extends to 1 minus f of x. Since x is approaching to 1 from the left side, graph is approaching to 2. And the right hand limit extends to 1 plus f of x. As x is approaching to 1 from the right side, the graph is approaching to 3 and the limit value is 3. The right hand limit is 3 as well as the left hand limit is 2. Again, at 2, limit extends to 2 minus f of x. As x is approaching to 2 from the left side, graph is approaching to 2, the left hand limit is 2. Again, limit extends to 2 plus f of x. As x is approaching 2 from the right side, graph is approaching to 2 and that value is again 2. So now if you observe, this both left hand limit and right hand limit are equal. Since these two are equal, in this case we announce that limit extends to 2, f of x is equals to 2. Limit exists and is equals to 2. But at minus 1, the left hand limit is 2, right hand limit is 3. These are not equal. So we say that limit is not exist, but left limit exists and right limit exists. But at the 0 again, the left limit and right limit both are zeros. So in that case, limit exists and that limit extends to 0, f of x is equals to 0. See, again at minus 1 also, the right hand limit exists, whereas the left hand limit is not defined. In that case also we say that limit extends to minus 1, f of x is equals to 1. Directly, as x approaches to minus 1, f of x approaches to 1, we will say. See, if you observe, all these are the limit values. But we are not concentrating about the functional values. Actually, to discuss the limit, no need to concentrate on the functional values. But here we have the graph, just have a look about the functional values. See, at minus 1, the functional value is again minus 1. See, again 1, right? At minus 1, the functional value is again 1, equals to the limit. And then at 0, the functional value is again 0, equals to limit. At 1, the functional value is not 2, the functional value is 3. It is equals to the right hand limit, not equals to the left hand limit. At 2, the functional value is not defined here actually. At 2, the function is not defined. The function not exist. 2 is not there in the domain of the given function. But the left hand limit is 2, right hand limit at 2, is true, but at 2 the functional value is not defined. And at 3, left hand limit is 1, right hand limit is -1, and the functional value at 3 is located here 0. F of 3 is 0. Left hand limit is some other value, right hand limit is some other value, and functional value is some other value. Right? So this is the way to observe the f of x tendency in the surroundings of a particular point on the domain. So if that particular point in the domain is A, then we say that limit x tends to A, f of x is equals to L, as f of x is approaching to the value L either from the left side or from the right side. If one side the function is not defined, then directly that other side is considered as the limit. If both sides are defined,